Behind the quantum computer emerges another groundbreaking super-fast computer. This is the optical computer, which have been revolutionized by the so-called optical technology. This is kind of exciting. Let's dive deeper into it. Optical computing, also known as photonic computing, is a revolutionary approach to information processing that utilizes light waves instead of the traditional electronic signals used in conventional computers. This innovative technology holds the promise of unlocking unprecedented levels of speed, efficiency, and data handling capabilities. At the heart of an optical computer lies the fundamental building block, the optical transistor. Unlike its electronic counterpart, the optical transistor manipulates light beams to control the flow of other light beams, enabling the creation of optical logic gates and the realization of digital computations using photons rather than electrons. The advantages of optical computing stem from the inherent properties of light. Photons can travel at the speed of light, unimpeded by the limitations of electron drift velocities that constrain electronic circuits. Additionally, light beams can pass through each other without interference, allowing for the construction of compact, three-dimensional architectures that are not possible with the wired interconnects of traditional computers. One of the key components of an optical computer is the optical processor, which performs the core computational tasks. This processor is composed of a network of optical logic gates, each capable of executing fundamental Boolean operations such as AND, OR, and not using light signals. By cascading these gates, complex algorithms and data processing can be achieved. Complementing the optical processor is the optical data transfer system, typically implemented using fiber optic cables. These high-bandwidth channels enable the rapid transmission of light-based information between different components of the optical computer, facilitating the flow of data at unprecedented speeds. These photonic-based AI accelerators can significantly enhance the performance of deep learning algorithms, enabling faster training and inference, while also reducing the energy consumption associated with traditional electronic-based AI systems. Despite the promising potential of optical computing, there are still several challenges that need to be addressed before it can become a mainstream technology. One of the primary hurdles is the development of efficient and scalable optical logic gates and integrated photonic circuits. Researchers are actively working on overcoming these challenges, exploring novel materials, device architectures, and fabrication techniques to create high-performance, low-power optical components that can be seamlessly integrated into a complete optical computing system. Another area of concern is the efficient conversion between optical and electronic signals. Since most existing computing infrastructure is based on electronic components, the need for optical-electrical (OEO) conversions can introduce latency and energy inefficiencies, limiting the overall performance of hybrid optical-electronic systems. To address this issue, researchers are exploring all-optical computing approaches that eliminate the need for these conversions, allowing light-based signals to be processed and transmitted entirely within the optical domain. This can lead to significant improvements in speed and energy efficiency. The integration of optical computing with other emerging technologies, such as quantum computing, is also an area of active research. The complementary strengths of these two paradigms can potentially lead to the development of hybrid systems that leverage the unique capabilities of both light-based and quantum-based computing. Optical storage solutions are also a crucial element of the optical computing ecosystem. Researchers have explored various approaches, including the use of photorefractive crystals and holographic storage media, to develop optical memory systems capable of storing and retrieving data using light. The power source for an optical computer is the optical power source, typically a laser or an array of coherent light sources. These light sources provide the necessary energy to drive the optical logic gates and enable the propagation of light signals throughout the system. One of the key advantages of optical computing is its potential for parallel processing. Unlike electronic computers, which are limited by the sequential nature of electronic circuits, optical computers can leverage the inherent parallelism of light, allowing multiple computations to be performed simultaneously. This parallel processing capability is particularly beneficial for applications that involve massive data processing, such as image recognition, pattern matching, and cryptography. Optical computers can excel in these domains, outperforming their electronic counterparts in terms of speed and efficiency. Another area where optical computing shines is in the field of artificial intelligence and machine learning. The ability to perform complex matrix operations and neural network computations using light-based processors has led to the development of specialized optical neural networks and photonic tensor cores. As the research and development in optical computing continues to progress, we can expect to see the emergence of specialized optical computing devices and the integration of optical components into mainstream computing platforms. This integration can lead to the creation of hybrid optical electronic systems that combine the best of both worlds, offering unprecedented levels of performance, energy efficiency, and data processing capabilities. The journey towards the realization of the optical computer is not without its obstacles, but the potential rewards are immense. With continued advancements in materials science, device engineering, and system integration, the dream of an all-optical computing revolution may soon become a reality, ushering in a new era of information processing that transcends the limitations of traditional electronic computing. As the field of optical computing matures, it is likely to have a profound impact on a wide range of industries, from high-performance computing and data centers to telecommunications and aerospace. The ability to process and transmit data at the speed of light can unlock new possibilities in fields such as real-time decision-making, complex simulations, and large-scale data analysis. Moreover, the energy-efficient nature of optical computing can contribute to the development of more sustainable and environmentally friendly computing solutions, addressing the growing concerns about the energy consumption and carbon footprint of traditional electronic systems. The transition to optical computing will not happen overnight, and it will require significant investments, collaborative efforts, and a willingness to embrace a paradigm shift in the way we approach information processing. However, the potential rewards of this transformative technology are too great to ignore, and the global scientific community is committed to overcoming the challenges and realizing the full potential of optical computing. As we look towards the future, the optical computer stands as a testament to the ingenuity and creativity of human minds. By harnessing the power of light, researchers and engineers are pushing the boundaries of what is possible in the realm of computing, paving the way for a new era of unprecedented speed, efficiency, and data processing capabilities. The journey towards the optical computer is not just about technological advancement. It is also a reflection of our collective desire to push the limits of human knowledge and capabilities. As we continue to explore the frontiers of optical computing, we are not only shaping the future of information technology but also inspiring the next generation of innovators and problem solvers. In the end, the optical computer represents a bold and ambitious vision for the future of computing, one that holds the promise of revolutionizing the way we process, store, and transmit information. As we continue to make progress in this exciting field, we can look forward to a world where the speed of light becomes the new standard for computing, and the boundaries of what is possible are constantly pushed forward. There has already been facts about the optical internet. Let's look into it. The optical internet is a revolutionary technology that utilizes fiber optic cables to transmit data at unprecedented speeds. Unlike traditional copper-based networks, the optical internet relies on the transmission of light pulses through thin strands of glass or plastic fibers. These fiber optic cables are capable of supporting much higher bandwidth capacities compared to their copper counterparts. The light signals can travel longer distances without the need for signal boosting, and they are also less susceptible to electromagnetic interference, which can degrade the quality of the transmitted data. The core of a fiber optic cable is made of ultra-pure glass, surrounded by a layer of cladding that reflects the light back into the core, and an outer protective jacket. This specialized construction allows the light signals to travel through the cable with minimal loss, enabling the optical internet to deliver data at speeds up to 800 gigabits per second, far exceeding the capabilities of traditional broadband technologies. The optical internet has a wide range of applications, from powering high-speed internet and cloud computing services to enabling advanced medical technologies and intelligent transportation systems. Its ability to transmit large amounts of data quickly and reliably makes it an essential component of our modern, interconnected world, one of the key advantages of the optical internet is its ability to transmit data over longer distances without the need for signal repeaters. This is particularly important for applications such as undersea communication cables, where the ability to transmit data over vast distances is crucial. Despite its many benefits, the deployment of the optical internet can be more expensive than traditional copper-based networks, due to the specialized equipment and installation requirements. However, as the demand for high-speed, the fundamental concept behind the optical internet is the use of light to transmit data through fiber optic cables. This is made possible by the principle of total internal reflection, where light signals are confined and guided through the thin glass or plastic fibers without significant loss of intensity. The light signals are converted into binary data, with light pulses representing 1 and the absence of light representing 0. This allows for the efficient and high-speed transmission of digital information. Another crucial concept is the ability to transmit multiple wavelengths of light through a single fiber optic cable using a technique called wavelength division multiplexing, WDM. WDM enables the simultaneous transmission of different data streams on separate wavelengths, dramatically increasing the overall bandwidth and capacity of the fiber optic network. 2. https://en.wikipedia.org/wiki/fiber-optic_communication. This has been a key driver in the exponential growth of internet speeds and data transmission capabilities over fiber optic infrastructure. The development of optical amplifiers has also been a significant advancement in the optical internet. These devices can periodically boost the light signals as they travel through the fiber, allowing for longer transmission distances without the need for frequent signal regeneration. This has been crucial in enabling the deployment of high-speed, long-haul fiber optic networks that form the backbone of the global internet infrastructure. Thanks for your concern on emerging technology. Stay tuned by subscribing and clicking on the notification bell on our channel to stay in touch with more amazing content we're deeply working on.